Welcome to this explainer. I'm seriously pumped to have you with us today because honestly, we are going on a bit of a ride. We're unpacking the wild evolution of artificial intelligence, taking you all the way from the deep academic mechanics of how AI actually thinks, right up to the fierce real-world economics driving how it's deployed today. If you've ever wondered how we went from simple image recognition to AI that can write code, and why the tech world is suddenly obsessed with running these massive models locally, well, you're in the exact right place. Let's dive in. Okay, so here's our roadmap for today. 1. A brief history of AI. 2. Generative adversarial networks explained. 3. Large language models and reasoning. 4. Overcoming AI limitations with RAG. And finally, 5. The shift to local AI. All right, Section 1. A brief history of AI. Let's zoom out a bit to see how we got here. It's honestly staggering how fast this tech is moving. Think about it. Back in 2012, AlexNet kicked off the deep learning boom just by getting really good at basic image recognition. Fast forward a mere 5 years to 2017, and the transformer architecture drops, totally changing the game for how machines process sequences. The very next year, Google gives us BERT for deep language understanding. And then, boom, 2022. ChatGPT hits the scene and brings generative AI straight to the public. I mean, we literally went from, hey, the computer knows this is a picture of a cat, to, hey, the computer just wrote my college essay, in exactly 1 decade. Crazy, right? Now, if you've ever felt completely overwhelmed by the alphabet soup of modern AI, you are definitely not alone. Let's break down these core architectures real quick. GPT, that's your go-to for generative tasks, creating brand new text. BERT is bidirectional, meaning it's hyper-focused on understanding the deep context of language, which makes it an absolute powerhouse for search and classification. Then you have T5, which basically turns every single problem into a simple text-to-text format. And finally, RLHF. This is the secret sauce, reinforcement learning from human feedback. It's literally how we align these massive models with human intent so they actually help us instead of, going completely off the rails. Moving right along to Section 2, Generative Adversarial Networks Explained. So to understand how AI went from just sorting data to actually creating it from scratch, we've got to talk about Generative Adversarial Networks, or GANs. Put simply, a GAN doesn't just categorize things. It learns the deep underlying patterns of a dataset to build stuff that has literally never existed. If you feed a GAN thousands of human faces, it'll spit out a hyper-realistic photo of someone you could swear you've seen at the grocery store. But they aren't real. The way this works is actually pretty brilliant. It's a classic forger and detective dynamic. You've got 2 neural networks locked in this constant, high-stakes competition. The generator is the forger. It starts with complete random noise and tries to craft realistic fake data. The discriminator is the detective. It looks at the real data and the generator's fakes and tries to spot the difference. And here's the kicker. Every single time the discriminator catches a fake, the generator learns from it and gets just a little bit better. This continuous adversarial loop forces the model to churn out shockingly realistic outputs. And this isn't just a cool parlor trick, it has massive real-world applications. We're talking about taking super low-res images and making them crystal clear, or turning quick pencil sketches into photorealistic landscapes. In the medical field, GANs are actively being used to improve the quality of MRI and CT scans, which is a literal lifesaver. But on the flip side, because they are so insanely good at generating synthetic media, this is the exact tech powering deepfakes. So yeah, incredible power, but definitely some very complex ethical challenges there. Oh, and game developers, they're even using this to generate entire virtual environments on the fly. All right, let's hit Section 3, Large Language Models and Reasoning. Let's see how all this translates to text. So we know how AI generates images, but what about processing text and mimicking logical thought? When we talk about a large language model reasoning, we have to be a bit careful. The model doesn't understand the world like you or I do. It's essentially just predicting the most likely next word based on massive amounts of pattern recognition. That is exactly why the way you prompt it matters so much. If you use traditional prompting, just asking for a direct answer, it's great for simple facts. But if you force the model to use chain of thought prompting, you're basically telling it to show its work. By thinking through a problem sequentially, step by step, the model's accuracy on complex math and logic tasks absolutely skyrockets. And what's really wild is that this reasoning is starting to leap off the screen and into the physical world. Enter Vision Language Action, or VLA models. These combine visual perception with language understanding. Imagine a robot that actually sees the room through a camera, understands you when you say, hey, pick up that red cup, and then physically moves its mechanical arm to do exactly that. This multimodal capability represents the absolute cutting edge of applying AI logic directly to real-world robotics. But look, we can't ignore the elephant in the room here. These models have some major flaws. The big one is hallucination. This is when the AI generates completely false or fabricated information, but delivers it with absolute, unwavering confidence. It's convincingly wrong. Then there's bias. Because these models are trained on the raw, unfiltered internet, they naturally soak up and reflect whatever social stereotypes and unfair patterns are buried in that data. They're incredibly powerful tools, for sure, but it is so important to remember they strictly mirror the data they're fed.
Which brings us perfectly to Section 4, Overcoming AI Limitations with RAG.
So how do we actually fix these confident hallucinations in the real world? Because, let's face it, retraining a massive multi-billion parameter model every time a single fact changes is just not going to happen. The industry's answer? RAG, or Retrieval Augmented Generation. Instead of letting the AI just guess, RAG basically forces it to do a quick external search first. It gets your query, turns it into searchable math, dives into a secure database to grab the exact facts, and shoves that context right into the prompt. Only then does it generate an answer. It's a massive structural fix that heavily grounds the AI in reality, drastically reducing those hallucinations. Finally, let's jump to Section 5, the shift to local AI. Okay, let's step away from the academic theory for a second and look at the fierce economic reality of all this. Our source material points to this incredibly fascinating concept called the triangle of death, which is the idea that you just cannot understand this era without seeing how technology, politics, and the economy are completely intertwined. You really can't grasp the AI industry by just looking at the code. This framework explains exactly why the AI landscape is shifting so fast right now. It is no longer just a race to see who can build the absolute smartest cloud model. The new race, it's about who can run these models affordably, efficiently, and securely. Because honestly, the economics of the cloud are becoming a huge bottleneck. When a company relies entirely on massive, closed cloud models, pinging an API on a giant server for every single prompt, the costs stack up insanely fast. I mean, the sources mentioned an engineer who accidentally racked up a staggering $23,000 bill just from API token usage. Yeah, 23 grand. Plus, shipping your proprietary company data off to a third-party server creates a massive privacy and security nightmare. The cloud paradigm is incredibly powerful, no doubt about it, but it's expensive and leaky. So how do we fight those massive costs and privacy risks? Well, the open source community is stepping up in a huge way. Check this out. According to a recent announcement in our sources, an absolutely mind-blowing 1 million models are projected to be uploaded or updated on Hugging Face, a major open source platform, in just a 90-day window. 1 million. That number is staggering. It signals a massive, aggressive pivot away from those expensive, closed, paper token cloud models and straight toward models you can download and run yourself. And how on earth are people running these huge models on everyday laptops? Ingenious software optimization. Our sources highlight two absolute game changers here. First, GGML. This is an architecture largely driven by a brilliant developer out of Bulgaria, and it essentially lets massive language models run hyper-efficiently on standard, limited consumer hardware. We're talking running powerful AI locally on your standard machine. Second, there's Unsloth. This specialized tool takes the usually grueling, expensive process of fine-tuning these models and makes it blazing fast and super resource efficient. The community is absolutely eating these tools up, and it's totally shaking the foundation of those massive, expensive API providers. You really don't need a massive server farm anymore to build a highly effective AI tool. Which brings us to the ultimate question, one that redefines the entire tech landscape right now. We've seen the incredible creative power of GANs, the step-by-step logic of LLMs, and how RAG builds a fence around their hallucinations. But economically, will the future of artificial intelligence be controlled by a handful of massive, highly expensive cloud APIs acting as the ultimate gatekeepers? Or will it be driven by millions of hyper-efficient, decentralized local models running right there on the hardware sitting in front of you? It is a fundamental shift, and it leaves us wondering who will ultimately control the artificial intelligence of tomorrow. Thank you so much for joining me on this explainer, and remember to always keep questioning the tech around you.